Hi everybody, we now solve together exercise 8, chapter 1, consumption decisions. N consumes shortbreads, good S, on the x-axis and candies, good C, on the y-axis, exclusively. And she's always willing to exchange 2 units of S for 3 units of C and has no monetary income but is initially endowed with 30 shortbreads. The price of shortbreads, PS, is 5 euros, while the price of candies is PC, 1 euro. Okay, so first point, compute N's marginal rate of substitution, discuss the relation that exists between the two goods, compute the monetary equivalent of N's initial endowment. So let's start from the first part of point 1, that is the marginal rate of substitution, okay? The MRS. First of all, let's give the definition of the MRS before we really compute it. So we should remember that the MRS tells us the number of units of good X, so in this case good S, that N is willing to give up to get one more unit of good C. So the good that lies on the y-axis, okay? And have, and that's essential, R utility unchanged. Okay? That is an overall definition for the MRS. Okay? Now, we know that N is always willing to exchange 2 units of S for 3 units of C. So from this piece of information here, we can actually compute RS. That is actually equal to 3 over 2. Why? Because, again, N is willing to exchange 2 units of S for 3 units of C. Okay? And this exchange makes N keep the same utility. So we can now move to the second part that is closely connected to this first part, that tells us to discuss the relationship that exists between the two goods. So it is easy to understand that since she's willing to exchange 2 units of S for 3 units of C, then these goods are perfect substitutes for N. Okay, so S and C are perfect substitutes for N because she's willing to exchange them at a fixed rate. Okay, so no doubt they are perfect substitutes. And now we can move to the third part of point 1 and compute the monetary value of her initial endowment. Okay, so the monetary value of her initial endowment is given by the quantity of good S that she has, 30, times their market price, 5. So it is 150 euros. And we have answered all the parts of point 1. Okay? Okay, so at this point, we are ready to move to point 2 of the exercise. Okay, and that's point 2. So let's see what we have to do now. Okay, so we have plot the family of indifference curves of the consumer, at least 3 curves, jointly with their budget line, clearly indicating the intercept, the slope, and the initial endowment. Find N's best choice and represent it in the graph. Okay, so let's do all these things. Okay, so first of all, we start from the indifference curves. Okay, plot indifference curves. Okay, in order to drop them, we have first of all to understand what's their shape. Okay, since we have perfect substitutes, we know that indifference curves are straight lines. They are straight lines. Again, since we have perfect substitutes, we know that perfect substitutes are particular goods, and among the characteristics, there is the one that indifference curves are straight lines. In order to draw these straight lines, we need to know the slope. Otherwise, how can we draw the indifference curves? Okay, and we know that the M, or we should know that MRS is the slope, obviously in absolute terms, of indifference curves. Of indifference curves. Okay, so in our case, the slope of indifference curve is minus 3/2 because it is equal to the MRS in absolute terms. The real slope is negative and it is minus 3/2. Okay, at this point, it is enough if we draw 3 lines whose slope is minus 3/2. Any of these 3 lines, the only characteristics that they must have is that the slope is minus 3/2. So, for example, let's take some numbers, like, first of all, we put S here and C here. Okay, for example, let's choose here 150, since this was the monetary value, just to start with the value. Then, if I take here 100, then here I have a line whose slope is 3/2. Okay, you see 3/2. I can take again any intercept, any line, as long as the slope is minus 3/2. Then other examples, 90 and 60, and that's another one. Or 30 and 20, that's another one. At this point, I have drawn 3 indifference curves. They are in green. Okay? You can draw again any other line, for example, 300 and 200, that's fine, as long as the slope is minus 3/2. Okay? And that was the first thing. Then, second thing here, we have to draw the budget line. Obviously, to draw the budget line, we first need to write the equation down. And it is PS, so the price of good S times S plus PC, price of good C times C equal M. So in our case, 5S plus 1C, so C equal 150. Okay? As you know, in order to draw a line, we can just rely on the intercepts, the vertical and the horizontal intercepts. Okay, so we start with the horizontal intercept. And how do we find the horizontal intercept? It's easy. We just put here in the budget line C equal to 0. And so we are left with 5S equal 150. So we have S equal to 30. So the vertical intercept is 30, 0. And now we move to the vertical intercept that we can find putting S equal to 0. And so in this case, always substituting into the budget line, we are left with C equal 150. So the vertical intercept is 0, 150. Now we can draw it, and I use now the blue color. I go back here to my graph. Okay, I have 30, 0, so here, and 150, 0, that it's already here. So that's my budget line. Okay, the blue line. So I have drawn the family of indifference curves because I have drawn 3 of them. I have drawn the budget line. I have clearly indicated the intercept. I'm missing the slope. Okay, so now we have to compute the slope of the budget line, but this is very simple. We compute it here. Okay, so the slope, we can simply compute it by computing the price ratio, so minus PS over PC, minus 5 over 1, so the slope is minus 5. Okay. Now, we need to find n's best choice and represent it in the graph. So here we have best choice. At this point, we should know how we find the best choice in the case of perfect substitutes. And the answer is that we compare the marginal rates of substitution with the price ratio. Okay? So when you have perfect substitutes and you need to find the best choice, you always compare the marginal rate of substitution with the price ratio. In our case, we have 3 over 2, and here we have 5. So it is easy to see that here you should put this sign, because 3 over 2 is less than 5. Okay? When this is the case, the best choice is a boundary solution, where the consumer, okay, consumes only the good that lies on the y-axis. Okay, so N will consume only C. Okay, so this optimal bundle is given by S star equal to 0 and C star equal to all the money that she has over the price. So in our case, 150 over 1, so 150. Okay, so the optimal bundle finally is E star 0, 150. Okay, and now we need to represent it in the previous graph, and we represent it using the red color. Okay, so now I show you again the graph here. Okay, and this is my E star. Okay. Now, at this point, we can move to, since we have done everything, we can move to point 3 of the exercise. Here it is, point 3. So, we have, suppose the price of shortbreads and the initial endowment are the same. So, we are told that PS is still 5 and money is still 150. Okay. Compute the change in the price of candies, so we need the PC prime, that would be needed in order to convince N to change her optimal choice, okay? So PC prime, so that N will change her optimal choice. Okay? This is what we have to find. So again, they are still perfect substitutes. So what we do is that we compare the marginal rate of substitution with price ratio, as we have done. Okay? But now, if N needs to change her optimal choice, I want this MRS to be no longer lower than the price ratio, but I want a change, so I want it larger or equal, okay, to the price ratio. So I repeat, since I want a change in the optimal choice of N, I need a change with respect to the situation that I had at point 2. So since previously the MRS was lower than the price ratio, now I want an MRS higher or equal to the price ratio, okay? So I substitute the values that I have. The marginal rate of substitution is always 3/2, larger or equal than 5 over, and I call this PC prime. I put it even here. If you solve this, you get 3 PC prime larger or equal than 10. So basically, you get PC prime higher or equal than 10/3. And now we comment on the result that we just got. So if PC prime is exactly equal to 10/3, what happens? Well, any bundle that exhausts N's money is optimal, okay? Is optimal. So any bundle will do, as long as the budget line is fully satisfied, okay? If PC prime is higher than 10/3, okay, then N will consume what? She will change her consumption, so she will consume good S only. So this means that the optimal bundle will be E star prime equal to good S. The good S consumed will be the amount of money over the price of S, 5, and 0 for good C. Exactly her initial endowment. Okay? That we can also represent the initial endowment here in the graph. So now I go back to the graph here. Okay. And the initial endowment is exactly this point here. Initial endowment. And at this point, we have answered to all the questions and the points of this exercise.